Hello everyone, let's do some numericals based on electric dipole. Question says a system has two charges plus 2 microcoulomb and minus 2 microcoulomb separated by distance of 0.2 millimeter. Considering the system to be a dipole, calculate the electric intensity at a point distant 1 meter on the equatorial line. Hence, find the intensity at a point 1 meter from the center on the axis of the dipole. So what is given here is we have two point charges whose value we call as minus q and then plus q, and the separation is given as 0.2 millimeter. Now the question says find the electric field at 2 points. One point is a point at a distance of 1 meter on the equatorial line and also a distance of 1 meter on the axis. Here the last statement says hence find. Hence find means that use the value of the electric field on the equatorial point, and from this we need to find the electric field at a point on the axis. So let's write the formula for the electric field at a point on the equatorial plane and a point on the axis. So the electric field at any point on the equatorial plane is given as K P by R cube, and this formula is true for a short dipole. A short dipole means that the distance between dipoles is very less compared with the distance where we need to find the electric field. Now here that distance is 1 meter, and this 1 meter is very much more than 0.2 millimeter. Hence this system is like a dipole. It's already given here also, it's a dipole. Also the electric field at any point on the axis is equal to 2 K P by R cube. If you compare these two, it's very obvious from here that the electric field on the axis or any point on the axis is equal to twice electric field at any point on the equatorial plane. So let's find what is E suffix E. It is equal to K P by R cube, and K value is 9 into 10 power 9, and P is given as Q into 2A. Q would be any one charge magnitude, which is 2 into 10 power minus 6 into the separation is given as 0.2 millimeter, which is same as 2 into 10 power minus 4 meter by 1 cube. That is equal to, it will be 9 into 2 would be 18 into 2 is 36. So 36 into, it's 10 power plus 9 minus 4 minus 6, which is 10 power minus 1, that is equal to 3.6 Newton per coulomb. Now we have found out the electric field at any point on the equatorial plane, and that value is equal to 3.6 Newton per coulomb. Question says hence find. Hence find means we need to use the data, or we need to use this value to find the electric field for a point on the axis. Using this equation, the electric field at any point on the axis is equal to 2 times E, that is equal to 2 into 3.6, that is equal to 7.2 Newton per coulomb. So this is the required answer. Question 2 says maximum torque acting on an electric dipole of dipole moment 3 into 10 power minus 29 coulomb meter in an uniform electric field is 6 into 10 power minus 25 Newton meter. Find electric field. We know that the torque for a dipole in an uniform electric field is given as P into E into sin theta, and torque is maximum when sin theta is equal to 1. So torque maximum is equal to P into E. Here, question says find the electric field, and here the dipole moment is given, that is P is given, and also here electric field is given. So torque is given as 3 into 10 power, no, that's not torque. Torque is given as 6 into 10 power minus 25, that is what torque is. It is equal to P is 3 into 10 power minus 29 into E. From here, 3 ones are 3 twos are. So E is equal to, it will be 2 into, if you bring this down, it becomes 10 power minus 29. Take it on top, it becomes 10 power minus 25 plus 29, that is 10 power plus 4 Newton per Coulomb. This is the required answer. Example 3 says an electric field is placed at an angle of 30 degrees with an electric field of intensity 2 into 10 power 5 Newton per Coulomb. It experiences a torque equal to 4 Newton meter. Find the charge on the dipole if the dipole length is 2 centimeter. Dipole length basically means it is distance between the two charges. So let's write data given first. What is given here is the angle which the dipole makes with electric field is given as 30 degrees, and also the electric field in value, this magnitude, is 2 into 10 power 5 Newton per Coulomb. The torque experienced is given as 4 Newton meter, and also the length of dipole, which is called as 2a, is given as 2 centimeter. Question says find what is the charge. Let's recall that torque is equal to P into E into sin theta. Here torque is equal to 4. 4 is equal to P. We'll just write P as it is now. E is 2 into 10 power 5 into sin theta is sin 30, which is half. It's half here. So from this gets cancelled, and what remains would be P is equal to 4. If you bring it on this side, it becomes 10 power minus 5. But P itself is equal to Q into 2a. So Q is unknown in 2a, which will be 2 into 10 power minus 2 in terms of meter. That is 4 into 10 power minus 5 is equal to. Now from here 2 gets cancelled, and also 10 power minus 2 gets cancelled from here. So finally what remains is Q is equal to 2 into 10 power minus 3 Coulomb. That is 2 millicoulomb. So this is the required answer.